Chapter 1 Video 2. So this video is going to be mainly concerned with the different types you can have in Java classes for your fields. So we've already done an animal class that's got some strings and some dates in there. So we're going to look at all the different types of Java primitive types we can have. Before we do that, just one or two things just to clarify from the last session. We coded a name field, and we've added some getters and setters for it. We added a getter and setter for the name, get name and set name. And in our zoo class, we create a new animal object, and we get the name there. One thing just to point out is we're using the getter to get the name. We can access that directly just by typing in the name there. So what you're doing there is you're pointing directly to the variable, to the field there. You're not going through the getter. Now, the best practice is to make this private, so it becomes a private variable. And then if we go back to the zoo class here, this doesn't work. It's gone red now, and it's saying the name has private access in the animal class. So what that does is it forces us to use the get name method. Now those two examples would work the same way, but this is considered the best practice. And when you look in the animal class, with regards to this variable name here, we're implementing strict encapsulation here. And what we mean by that is we've defined a property, a field called name, but we've marked it private. That means nothing else can touch it directly. The only way you can have access to it is by use of these public methods which use that name variable, which other classes can use. So encapsulation is a way of taking control of the data in your own class and making sure that other classes can use them only in the way you specify through your public methods. So that's encapsulation. One other thing, just before we start talking about the different data types, is initializers. So here we have methods, and methods have curly brackets to define their method body. You can also have curly bracket sections without any method structure, like that, basically. And these are called instance initializers. So I'm just going to show how these work, let's just put a system out there. So instance initializer 1 there. I'm going to copy all that code again here and put it underneath here. There we go, like that. And initializer 2, that will be. And what these do is when a new instance of a class is created, and if you remember you do that by using the new keyword and then calling a constructor, these instance initializers will be executed when the class is created. So let's put another system out in the constructor. We'll trace this through now. Let's put another comment here called constructor, and we'll put yet another one at the top, and this time we'll add our curly brackets and we'll put that line in them like that. But this time we're going to label this this anonymous section the static. So this is now a static initializer, and static, the idea of static is something that belongs to a class rather than any instance of a class. So when the class is loaded, and it only gets loaded once for the whole life of the Java virtual machine, this will get printed. I'm going to change that to static initializer. So to demonstrate this, what I'm going to do, I'm actually going to run our zoo program, because the zoo program calls the new keyword on the animal class twice. So let's go to run zoo and just see what happens in the output. So here's the output of doing that. I'm going to just scroll this up so you can see the whole lot here. There we see. So we've called static initializer 1 gets called only once, even though we've got two instances of that class. The class itself gets loaded only once, and that's the first thing that gets called. Then, when we create an instance by creating the new keyword, these two static initializers are called, and they get called in the order that they're defined in the class. And then the constructor is called. Then we have a second instance created, instance initializer 1, 2, and then the constructor again. So that's the order they're done. Static initializer is always done first and only once. Instance initializers are done each time you create a new instance of the class, and they're done first because, as you can see, the output from the constructor only occurs after they've happened. Then we have the normal running of the program, as you saw in video 1. So these fields that we created so far are instance fields, and that means that when you create an instance of the class using the new keyword, the instance gets a copy of all these fields all to itself. We can see that they're instance variables because they don't have the static keyword. But let's add a static keyword to demonstrate a bit more about what static means and what class variables are. And we'll call this, we'll make a static int, because int is integer, that's a numeric type. We'll call it no of animals, number of animals, like that. And so this is now a class variable because it's static. That means that it's created at the level of the class, and all the different instances, no matter how many you create, in our program we're creating 2, but you could create 2,000 if you wanted, they all point to the same variable here, whereas in these ones they've all got their own copy of it. So if we demonstrate that in action, if we say that every time we create a constructor, every time we create an animal, we increment that by 1. And the way you increment in Java, as we'll see in a minute, is ++, like that. So, and integer variables get initialized with a value of 0. So this will get incremented every time you create an animal. So it's a way of keeping track of how many animals we've got. So I'm back in the zoo class, and I'm going to print out something else to the console. This zoo has, and we're going to reference that class variable we just created. And the thing about class variables is you can reference them directly, like that. Animal dot number of animals, and then plus. And one thing to note is that we've got 2 instances of this class called tiger and elephant. We could reference that class variable through one of the instances if we want to, but it's best practice not to, because it's a class variable, so it's best to reference it from the class itself rather than an instance of the class. We can do it through an instance, but that's misleading. This is the best way to do it, and somebody reading this code will have no doubt that that is a class variable. And there's the output. We have our output that we had before, but we also have this extra line here. This zoo has 2 animals, and that's because each one of these 2 instances incremented that class variable each time they were called. So this went from 0 to 1 when we created the tiger, to 2 when we created the elephant. So that kind of visualizes what class variables are used for. They're something that the whole class looks at. Every instance of the class looks at the same variable. These other variables, like the word name, for example, the field name, that's the value of that is only of interest to the particular instance we're in. So when we created a tiger, we set the name to Terry in that first argument, and the elephant when we created to Erica. That Terry and Erica are completely unrelated to each other. They're in copies of that name variable that are completely invisible to each other. So that's how you distinguish between class and instance variables. Now what you can see here is I've created some new classes here to really start to talk about the different types of that we use in Java. So we've already met string, and we briefly met int there. Let's open this class and we'll see all the Java primitive types. And these are all, this first section is all class variables. And you can tell they're class variables because they start with static. So however many instances of this class we create, there's only ever going to be one copy of each of these variables, and if one class changes the value of that, it will be reflected in every instance. So there's 8 Java basic types in Java, basic primitive types. I'm going to scroll this down so we can see them on one screen. The first one is a Boolean, and it's just 1 bit in size. So it can basically only take the value of a 0 or a 1, which is obviously what a bit is, and that represents false or true. So a Boolean is the smallest data type, and it's used quite commonly in Java because it produces a simple true or false, which is obviously the root of a lot of decision making, such as in an if statement, for example. Then the next 4, they're all numeric types. Numeric types are without a decimal point. and they go in increasing size. So a byte is 8 bits, short is 16 bits, int is 32 bits, and long is 64 bits. And you don't need to know how to calculate what the maximum values these data types create. The book just advises you to know how to work it out if you need to. So like a bit can take 2 possible values, 0 or 1. So a byte, therefore, which is 8 bits, can take 2, which is the possible values of a bit, to the power of 8. And that gives you an answer of 256. So a byte can contain 256 possible values, but because it also incorporates negative, the range of a byte is minus 128 to positive 127, like that. And in the same way, you could work it out for a short, an int, and a long, which is obviously the largest of the non-decimal point numerical types. You rarely see these used anymore, byte and short, because these days memory is not such an issue with computers. Obviously in the 80s and 90s that would have been a big concern, but now people tend to use int as their default. That's by far the most popular numerical type. Or if they know they're going to be using very, very big numbers, such as in nuclear physics or something like that, that they can use a long. The next two, we have float and double. 32-bit and 64-bit respectively. Those are numerical types, but they incorporate a decimal point. So when you're handling decimals, these are the two to use. And double tends to be the one used by default. Finally, we have a char, which represents character. It's 32-bit, and what it technically is an unsigned int. What it's practically used for is holding the value of a character. So you could initialize it to this, for example. But actually, none of these have been initialized at all. They've been declared, but they haven't been given a value. In other words, they haven't been assigned. They haven't been initialized, and that's okay because class variables will be given a default value. So here are the 8 primitive types, and you'll notice that string isn't there. We've been using string a lot so far in our examples, and it's not there. Why not? Well, it's because it's not a primitive type. String is actually an object, and I've got some examples here of some class objects. So we've got a string called my class string, and just object, my class object. Because object is the superclass of all Java classes. So these objects are Java classes that you can create an instance of, just like we created an instance of animal. We created an instance of the animal class. We created 2 instances in our zoo class. These are just primitive Java types. So when you create an int, it simply puts the value of the int in memory. When you create a string, it actually creates a string object and stores that object in memory. So here are the 8 primitive types, and I've added some class objects as well just to demonstrate the difference. Then underneath that, exactly the same set of 8 primitives and objects, but these are instance variables. So the only difference is they don't contain the word static. So that means they're not visible at a class level. You have to have an instance to access them. And when you do create an instance, that instance gets its complete copy of these all to itself. Now what we can do to demonstrate this, I've got a main method here that's going to print out the value of all those fields that we've declared above. This section is for the class variables. They've got class in the printout, and these are the instance ones. And you'll notice that to get to the instance ones, we first have to use the new keyword to get an instance. I called it test. Test in new, one of these classes, and then we reference them with dot and then the name of the variable. So we'll print that out and see what we get. So this is now run, and as you can see, we didn't initialize those variables at the time we declared them, so it's given them the default values. And the rule of thumb is that the default value it gives are always the lowest possible value it could do. So for our boolean, it's been defaulted to false. All the others are the numeric types are all 0, and the char is basically an empty, and our objects are null. So when you have an object that you declare but don't initialize, it gets initialized to null. Then we have our instance variables, and these are exactly the same values, all the lowest possible thing they can have, zeros and null for the objects. I just have to scroll this up a bit so you can see the null values there. So that is class and instance variables and their default initialization. And what we can do, we can look at some examples here where we do initialize them. So here we have, and I've just given the example here of these are instance variables because they don't contain the word static, and but the same will be true of static variables. And this time we actually assign something using the equals operator, the assignment operator there. So we're telling it that our boolean is true, our byte is 127, which is actually the highest value a byte can take, a short, an integer. Again, this is the highest value that integer can possibly take, a long, a float, a double, and a char. And we've got our objects as well, where we're saying that so we're going to have a zoo object, and we're also going to have an animal object. But this is just to show that animal object ultimately is a subclass of object, because we're saying we want an object, and that object is a new animal. And the compiler can see that animal inherits from object. It does it implicitly, and so it allows that to compile no problem. So those are our instance variables, and now we're going to, in the same way as before, we're actually going to print the value of those variables there. So let's run that class. So we've run the class down. Here are the values. Everything that we specified earlier on has been saved, which is excellent. And our objects, this looks a bit strange, but this will become clear later in the course. What we have here for our objects is we have this strange sort of this strange notation here. This is the fully qualified class name with the package, and also a strange number after the @ symbol. That number is basically just the area in memory where this object is called. It's the object reference, and that will become more relevant later on in the course. So that's basically how you declare and initialize instance variables and class variables. And we're going to look at the other type of variable in a minute, which is local variables. First of all, just to point out a few things that you need to be aware of. So this integer here is the maximum value an integer could be. So if I add 1 to it, that doesn't compile anymore because the compiler recognizes that it's too large. So let's change it back again, and it compiles okay. So now let's use that to look at a long. So I'm going to put the value of the maximum value of an int into a long, and that compiles fine, as you can see there. But what's surprising is if you add 1 to that, you would expect that would be fine, because we're now in a 64-bit type rather than the 32-bit type. Let's see what happens. Again, it fails, and if we hover over it, it's saying the integer number is too large. This is a bit baffling at first, because you think, well, I know it's too large, that's why I'm assigning it to a long. But the trouble is, the reason that doesn't work is that the Java compiler looks at every single token in turn. So it looks at here, we've got 1, 2, 3, 4 tokens, and it compiles them separately before then looking at the line as 1. And when it looks at things separately, as soon as it sees a numerical type like this, it assumes that it's an int, because int is the default Java type. And when it sees that it's bigger than an int, it complains like that. It might not seem very intuitive, but that's how Java works, and there's an easy way to get around it. We simply suffix it with an L, like that. Now that compiles. L stands for long. We could use a lowercase l, but it's best not to, because that looks very much like a 1. So let's just do that. And even though you could do it for smaller types, for numbers smaller than a maximum size of an integer, like 2, we could get away with just 2 there. But it's good practice when you're dealing with a long to actually spell it out, to actually say no, this is a long. We want the L there, even because presumably we're going to be doing manipulation with that later and making it larger. But just to make it clear, we'll call it an L right from the start. So in a similar way here, when we have a floating type number, so this is a decimal, we have to suffix it with a large or a small f. Either will do, because if you don't do that, the default for a floating point number is a double. So in the same way here, when it sees an integer like that, when it sees a number without a decimal point, it assumes it's an integer. When it sees one with one, it assumes it is a double. So if it's just a float, you need to put the F there. A double, you don't need to do anything, because by default, a decimal type is a double. And then finally we have our char. So that's just to explain the quirks of how that works. So we've dealt with class and instance variables. Let's look at local variables now. So local variables are variables that exist just within a method. So you've got we've got all the same types that we had before. This time they're defined within the main method. This also is local because this is passed in as a parameter, string args. So the thing about all these methods is they're not visible outside that method. So the scope is lower. So basically the scope, the most visible scope is a class variable, then an instance variable, then a local variable. They're only visible within the method in which they're declared. And what you can't do with a local variable, you can't just not initialize it like that. You see, that complains when we try and print it out later, because it might not have been initialized. We can't rely on default initialization for local variables. We have to do it ourselves, but we can do it. We don't have to do it on the same line. So this byte, for example, here is declared here and initialized here, but and it compiles. But we do have to do it at some point before we use it. So again, if I comment that, this doesn't compile. So you need to initialize them. Another thing about local variables is that the access modifiers do not work with them. If you do that, for example, it will tell you that this modifier public is not allowed here. It makes no sense to use access modifiers within local variables because they're only visible within the method they're created. So making them public, in other words, telling them that any other class, any other user can access them, makes no sense because they're only visible within that method anyway. So you can't use access modifiers with local variables. Otherwise, all the types and the rules are the same as that we've already discussed. So I'm going to just run this one and print and see what the printout is. So here's the result of running that class, and as you can see, we've got all the variables that we initialized at the local level, the local variables. So that's covered all the 8 different primitive data types, and the fact that you can also have objects as fields as well, at the 3 different levels of scope: class, which is defined with the static keyword, instance, and local, which are only defined within methods. So some basic rules about naming variables now. In general, the best practice is to use camel case for variable names, where the first word is in all lowercase, and then any subsequent words just start with a capital letter and then use lowercase. That's in contrast to class names, which are camel case with even the first word capitalized as well. There are certain things you can't do, so you can't have a number as the first character like that. You can have myshot2 if you like. Another thing you can do is you can put a dollar as the first symbol, the dollar sign, so that's fine. Or you can have an underscore as the first character, and that's fine. No other special characters and no other reserved words are allowed. And there's a big list of Java reserved words on page 28. And the nice thing about that is that list of words is you used to be able to have to memorize all of those for the exam. The only ones you'll be tested on now are ones that we actually come across during this course. So don't worry too much about that list on 28, but preparing for the exam, it is definitely worth studying it, but you should have come across all the words that you'll be tested on anyway. You obviously can't use any of those reserved words for variable names. The best thing is simple camel case variable names. And other things you can do is, the best way to illustrate this is to go to look at some instance variables here. You can declare multiple variables in the same line. So you can do boolean my boolean equals true, comma, your boolean. So you're declaring 2 variables on the same line. My boolean you're actually initializing to true. Your boolean you're not initializing, so it'll be initialized to the default value of false. Integers, you can do as many as you want, so you can do let's do A, B, C, D, E, F, G, like that. So that's initializing multiple integers at the same time. And unless you specifically initialize them, they won't be, they'll just be initialized to 0. But let's just make D to something. And that's all fine. That compiles fine. Multiple declarations and initializations on the same line. It's perhaps not the best to look at, but you just need to be aware that it's possible to do that. Just a note on the ordering of the elements of a class as well. If the class is within a package, the package declaration has to be the very first thing. And if the class imports other classes, imports have to be the next thing. Then we have the class declaration. Then we have the elements within the class, so the fields, constructors, methods, and we showed some initializers before as well. I've commented this one out and deleted most of them because it was producing too much output, but they can basically go anywhere. And it's best practice to keep things in a logical order, so fields, constructors, and methods is an excellent order to keep them in, more readable. You could theoretically put them in a different order, so you could put the... I've temporarily deleted that name variable, but I can paste it down here, and these all compile again. You notice that if we delete it completely, they go red, but if we put it back in anywhere, even though it's declared underneath there were those methods that use it, they still compile. So you can have things basically anywhere in the class, but obviously it makes much more sense to put them in the logical order of fields, constructors, methods. Another Java reserve word, which would be a good one to introduce at this point, is the word final. And I'm going to put it in the main method here. I've got final there. Or it would also work if it was before the static keyword, if it was there. And final basically just means that once this variable is declared, it can't be changed. It can't be that you can't subclass the class you're working on and then redefine that main method. So you're basically saying this is the definitive method main, and I'm declaring it here, and you can't change it. You rarely actually see it in the main method, but the examiners do like testing on that. They do like you to know what valid structures of the main method are. So the final keyword is sometimes shown there in questions, but it's much more likely in the real world to be in a method that's like a very mature method. Works very well, and no one wants you to change that afterwards. But it works. It does work in the public static void main method. Another thing, while we're talking about the structure of the main method, I already mentioned it in video 1, but just to say again, that is also valid for it. 3 dots after the string. It's just a new way of representing a string array. And garbage collection is another thing that's covered in the book. Garbage collection is basically the process that Java uses to destroy any objects that have been created that are still in memory, to free up memory, basically. So, example here, we've got some animal objects here, and they're used here, and then they're not used again after that, so they're eligible for garbage collection. They're eligible to be destroyed. And what you can do, you can try and call the garbage collector yourself. And there's a method for doing that, system, and that's the same system class that we're using system outs for here, system.gc. So what that means is that you're encouraging the garbage collector to go and clean up objects that are no longer used anymore, no longer required anymore. The key thing to remember is here, you can't force garbage collection. This is another thing that they sometimes examine you on. If you get a question saying, how can you force garbage collection? You can never force it. You can just encourage it. That's encouraging it to do it there, but you don't know when it's actually going to do it. That's kind of the JVM decides that for itself. And another thing you can do regarding garbage collection is that if you're an object that may be about to be garbage collected, like these animal objects, you can define a method on the animal. So let's go to our methods section down here and put a new method in here. And again, this is a standard method that comes from the object class. So we'll go to generate and override methods, and we'll get finalize there. And it fills it in for us, and it tells us this is an override method. We've overridden it from our superclass. And you can just do whatever you want there, and this is what it will do just prior to being destroyed by the garbage collector. So it's almost like a last request to what do you want to do. So I'm going to put fine toast. It's just about to be destroyed there. When I say that's extended, that comes from the object class. As we mentioned earlier, all classes ultimately inherit the extend from the object class. Because what you can do is this: extends object, like that. Extends is the way that you say what the superclass of your class is. So public class extends animal, but you don't have to. Extend the object class because it does that implicitly. All objects implicitly inherit from object. If you try to extend a class like string, it would complain about that. It's saying you can't inherit from Java string, and the reason why is that class is a final class. You see the final keyword there in the middle. So we talked before about being able to use the final keyword in methods. Well, here it is being used actually in a class declaration, public final class string. That means that the Java people who wrote the string class don't want you to mess around with it, basically, that they're happy with it and they don't want you to extend it and change it in any way. So that's why we can't do that in the animal class. Not that we want to, but it was just an illustrative example. So all we're going to do, we're not going to do anything because we implicitly extend object anyway. So the chapter basically closes by just talking about a few benefits of Java, and it gives the point that Java is an object-oriented language. In other words, it's not a large procedural language. It defines its building blocks as classes, as we've done, and those classes are assembled together to make an executable program. And each class contains its own properties and methods, or fields and methods, and it tends to encapsulate its own data within its own class. The object-oriented paradigm is a very popular one, and it tends to make for more reusable, maintainable code, because when you have to make a change to it, you tend to just make a change to a certain class rather than one huge procedural program where you might have to make changes in several places. And Java is platform independent. So when you create a class file, and we did that in video 1 by calling the Java-C tool on Java source files to produce a class file, that class file is platform independent. So it's important to know that class file is not native machine code for whatever machine you're working on. It's byte code that runs in a JVM. And the JVM will know what platform you're working on, because when you install Java in the first place, you installed the version of Java for your environment. So you can take compiled class files and drop them in any JVM in any platform, and they should run. And of course, many class files together tend to be put into jar files, so Java archives, and that's how we tend to distribute our Java classes in the form of jars. And again, they're platform independent. The class path of any particular machine you're on just needs to be made aware of them, and they're automatically usable by the Java running on that machine.